I'm not very confident.
All right, that's okay. We can work with that.
All right.
So go ahead and guess then.
Sorry, I'm just still trying to look through. I have this all down in my notebook somewhere. I just can't find the exact page it's on.
All right, Jenna, what do you think?
I'll be back once I find it.
You out there, Jenna?
Yeah, oh, sorry, I wasn't unmuted. So I just did the normal distribution on Excel. So I did equals normal distribution and then 8, 17, 3, and then true.
Okay. And
Yes.
so in other words, what value did you put in 8 for X?
Yes.
Okay, which is correct. Because 8 is our single value X. Everybody see what I'm pointing at on my screen? Okay, so what Jenna did is fine. You can use the Excel functions or you can do this way, whatever you feel comfortable with. All right. And so what was the gold at the end of the rainbow there, Jenna?
You get 0.13.
Was it 0.13 or 0.0013?
Oh wait, so 0.13% then.
Okay. All right. Super. Okay. Let's move on to Q2. All right. So the bottom line is, folks, that Q1 on the Bombtrack, the squad drive, is for that, I think that entire problem, we're in this forest here. Single value forest. Okay. And we chop down a couple trees up here. All right, let's go on to Q2. Let's see who's on tap for Q2. Tim out there tonight? I'm sorry I have to ask this way because when I share my screen, I can't see you guys anymore. Okay, Carrie, start us on Q2. Just go with Q2 alpha.
Okay, so I just started this one. I'm a little confused. I started like looking at the chart that you shared.
Okay.
And do I use the sample mean equation? That uh-oh, it just went away. Hold on, I'm trying to find it. The one it says what is given and then sample mean. Would it be the X? That one, where you're at. Yeah. Okay. So that's what I've set up, but I'm like having a hard time figuring out what to put in there now.
Okay, so let's take down what we know. What is the mu? What is the mean for the population?
Is that the 20 they gave us?
It is.
Okay.
And so if that's 20, what is this go phi sig down here? What is that?
That's what we don't know, right?
Remember, these are brother and sister.
Yo, I got my stuff. I'm ready to hop in.
Okay, Tyler, what do we put in for sigma here? If we're using this formula, we're now on Q2 alpha.
So that's the standard deviation, which is 3.
Yes. You tracking, Carrie?
Oh, so that's still 3 for this question?
Yep.
From the question above?
Yes.
Okay, I didn't know they. Okay, that's where I was confused.
Remember our big back tattoo, right? Let's see if I can pull it up in 10 seconds, then I'm the man, and if not, I'm not. 1,000, 2,000. All right. I can't pull it up real fast.
That's the chart, right? That like says what sample and everything. Because I think I found it in my notes. If it's
All right, so check out my screen. And oh, by the way, I am recording this, so you can go back and watch this later. It's not like I'm recording this to whatever. I think I got my screen up. My whiteboard's not wanting to play ball. I guess I have too many things open. The bottom line is that, okay, you see mu and sigma go together. Population mean, population standard deviation. Okay, so usually when we know the population mean, most of the time we know the population standard deviation. All right, so let's back on track. So if 20 goes for the mu and 3 goes for sigma, then what goes into the rest of this? What goes in for x or x bar? Jenna, what do you think?
So X bar is, or is, hold on, can you say the question one more time? Sorry.
Yeah, no problem. All right, so we're on Q2 alpha. All right, I'll just read it. For the past 6 years, the Joker has attempted to detonate bombs around the world. Flash, flash. You don't care whether it's been 6 years or 6 months. The 6 years doesn't mean anything. You don't need to do anything with the 6 years. Batman has been able to capture the bursting radius of 9 of these bombs. So we have a larger group of bombs. We don't know exactly how many, but we know that Batman's been able to capture 9. If Dr. Heisenberg's assumption about the Joker's bomb production from Q1 is correct, then what is the probability that Batman's sample mean is greater than 20 miles? So we've agreed that 20 goes in for mu, 3 goes in for sigma. What goes in for x bar?
Would that still just be the 17 there?
So the 17 was the single value. Now we have a sample mean. So
So that one's the 20 then?
yes,
Possibly? Okay.
yes. Because the
I have a-
sample mean is greater than 20. So we're going to throw that 20 in there. And then what's going to go down there for n?
that's the 9.
Super. Okay. So from there, I think we kind of know. Does that help you out, Carrie? We know what to do.
Yeah.
All right, we're
I have
going to get
a
there.
question.
What's that?
I have a question how we got 20 for the mean.
Yeah. So when we look at the problem, what is the probability that Batman's sample mean is greater than 20 miles? So essentially, that's giving us the sample mean. Another way of saying that is, what is the probability that Batman's sample mean is 20 miles or greater?
So that would be both the mean and x bar.
Now that would be X bar. Yeah, well, you're right. Because, wait a minute.
Because I just like how I interpreted the question was like I pulled down the 17 and the 3 from question 1.
Right? So 20 would go in for the X bar. 17 would go in for mu. I think I said 20 earlier. I was wrong.
Yeah. Okay.
Okay,
That's
so
what
I
was-
apologize. Yeah, you are correct. I'm wrong.
Okay.
So, but what you did was the right thing to do. Good to go?
Okay.
All right. Where are we at? All right, let's go on to B. So the probability of A is 0.0013. And let's see here. Cameron, what do you think about Q2B?
Right now, I did that completely wrong, and I was trying to fix it before, so I do not have an answer for that.
Okay, that's all right. Alexis, what do you think?
Um, 100% sure.
Okay. So let's see here.
More.
So yeah, go ahead.
No, I wasn't sure. I reread it.
Okay.
I'm not sure.
All right. That's okay. All right. So here's what we're looking at, folks. We have, first, we start this thing out. All right. So we have this expert Heisenberg who says, oh, the population mean is 17 with a standard deviation of 3. And so we start saying, okay, we essentially have a sample size of 1. We have single value X. And we ask the question, what is the probability that a bomb would be 20 miles in radius or greater? And that answer is just under 16%. Okay. So not super high, but it's 16%. Now, Batman turns out he has a sample size of 9. He takes a sample average, and then he determines the probability of the sample mean being 20 miles or greater. So he has more than a single value now. He has a sample size of 9. And the probability of the sample mean being 20 miles or greater is less than 1%. So Noah, what do you think about that?
I said that I think it gets smaller because as the sample size increases, the average will regress towards the population mean.
Very good. Everybody hear that? Okay, so remember, this is like, Travis, how tall are you? You're like 6'2". Travis, pretty tall guy. The first time I think I realized that I'd only talked to Travis like when he was sitting down because I'm his advisor. And then one day I saw him standing up and I was like, holy cow, sample size of 1. But then I gather a whole bunch of other people and probably, so if I was to gather Travis and I would say, okay, sample size of 1, 6'2", but then I get Noah and I get Matt and I get Colin and I get Connor. And pretty soon the probability of the sample mean being 6'2" or greater goes down. See what I mean? Because I'm drifting more towards the mean height, which is probably more about 5'11", my height. This makes sense? So what Noah said is absolutely accurate. And what is also important is that now this probability is no longer 15%. Now it's much, much lower. If I told you yesterday the probability of us coming back this semester is 15%. And then I told you today it's less than 1%. See what I mean? You might say, well, dude, we got to make this online thing work rather than just putting up with it. All right, because we're going to get a box of Snickers because we're going to be here a while, kind of thing. All right, so that's what that means. That's what Q2 Bravo means. Let's move on to Q2C. And Noah, why don't you give that one a shot or get us started on that?
Just give me 1 sec to read.
Okay. And if you're doing it for the first time, that's fine. Just kind of tell us how you would approach it, what you would do.
Okay, so we're trying to find the probability that it's between those two values.
Very good.
So first what I did was I tried to find the z-score if the radius was 20 or the sample average is 20.
Okay.
And that gave me 3, which when I looked at the z-table gave me a probability of 0.9987. And then I found the z-score for when the sample average is 17, which is 0. And that's a probability of 0.5 on the z-table. And then I subtracted 0.5 from 0.9987 to get 0.4987 or 49.87%.
Okay, good. Everybody see that? So that's not a single value. That's a sample mean in between type of problem. Okay. Okay. We'll move on to Q3. So let's see here. Anna Grace, you want to give Q3 Alpha a shot?
I didn't do this one because I thought we were only supposed to do like the one that was assigned to you.
Okay.
But that's okay. We can go through it.
Yeah, you want to give it, I mean,
yeah, that's fine.
It's all good in the hood, unless you're wearing like a bright yellow or green. Anyway, I saw that behind that. Anyway, yeah, just go for it. Just you can read it out loud, do whatever. Just tell us how you would approach it. You don't have to solve it out loud. Just tell us how you would approach it.
Okay, so it says to estimate the radius of the bomb, Batman decides to build a 95% confidence interval. What should he tell the mayor about the bomb's bursting radius?
Yes.
Okay. So I guess we would have to look at your chart first.
Okay. I mean that table up there that's up above it?
Yeah. Or the one that you like posted online. I honestly don't know where to start.
Okay, that's okay. Alexa, you want to give this one a shot?
So I took the numbers that were in the table like under question 3, and I found the mean and the standard deviation of those numbers, the sample standard deviation. So for X bar, I got 9.23, and the sample standard deviation, I got 1.24. And then I used those in the formula. That's the mean equals X bar plus or minus T, and then the S divided by square. And then, do you want me to just say the answer then?
Yeah, if you want to.
So for the upper value, I got 9.84, and for the lower value, I got 8.62.
Okay. I got to check my numbers, but I think yours is correct. and it might just be because I don't know. I don't trust my numbers anymore because it's the second time today that I've heard they're kind of funky. But Alexa, why didn't you use a z-score?
Because you didn't have the we didn't have the standard deviation, so we had to use it's like the degree of something, the DF number. I don't remember what it's called.
Yeah, it's the degree of freedom. So
Okay.
always remember that just because I asked you a question doesn't mean there's like a triple negative. Just because I asked you a question doesn't mean you aren't correct. All right. So sometimes I do that not to mess with anybody, but just to, so you'll increase your confidence in your answer. Not that Alexa wasn't confident. So this is what Alexa was talking about. Can everybody see my screen with Mike TV down here whining, shrinking? So when we don't know the standard deviation for the population, well, first of all, we're in the forest of confidence intervals. That's where we are right now because the question asks for a confidence interval. And so Alexa has gone down here. If we estimating the mean or proportion, we're doing the mean. And do we know the population standard deviation? At this point, that question is the $500,000 question that's going to separate us here and take us, we'll either go this fork in the road or that fork in the road. Because Batman is abandoning the expert's assumption about the population. We don't have a standard deviation for the population because Batman's gone, I don't believe this guy. I'm going to do my own thing because that's what Batman normally does. Now, do I have my T table? I do somewhere. And let's see here. Just bear with me. It's hidden behind here. Or is it? Oh, well. That's my Z table. Yeah, there it is. Way the heck down there. Okay, so we need two things. That's what Alexa was talking about going into the T table. The first is that degrees of freedom thingy, to use the technical term. Because N is, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. N is 13. So our degrees of freedom is N minus 1, which is 12. And then we're going to walk over to alpha half when we're doing a T, or when we're using a T-score, we can still cheat and use alpha half off this table, even though it's a shortcut for the Z table, but alpha half is alpha half. So we can still use that, and alpha half is 0.005. So we have 9, and we're going to walk over here. No, I'm sorry. We have 11. Help me out. Is it 11 or 12?
Could be 12.
It would be 13. So degrees of freedom is 12. You're right. So 12, and then we walk over here to 0.005, and that's that number, which is where I think I messed mine up. Did I do all that right?
Aren't we
Trying
going
to
up to 95%, which would be the 0.025?
Yeah. Is it 95? That's what I was doing wrong.
I had that wrong too, so my answer was not correct. I didn't get the right number, the right value for T.
Okay, so that might have been where our answers are different. So
Yeah.
let's just recock on this. So it's 95. Our alpha half is 0.025. Our degrees of freedom is 12. So we're going to grab 12. We're going to go over here to, I'm still not getting the value I had earlier. What am I doing wrong? Ah, here. Right there. Like Cameron said, 0.025. That gives us a t-value of 2.179. And we put that into this formula right here. Now, notice also what Alexa did. She computed S, the standard deviation, for that data set. So she computed, of course, the sample mean, which is that value right there, 9.2 and some change. And her standard deviation, I think, was correct, is 1.23, Alexa?
I
Something like
did.
that.
I had 1.24, but I mean.
Yeah, actually, you are correct. It is, I'm reading it wrong off the sheet. So she put that there, and then she put the N of 13 right there. And then she got her upper and lower, which looks a lot like this right here. We know that because she didn't use a different t-value, that's where that was different. Okay? So the main thing out of all those nuts and bolts, I think, is when you're doing a confidence interval, if you're doing a mean, this is your $500,000 question. Your $1 million question is, what forest should I be in? Okay. Once you get into this forest, your $500,000 question, assuming you're not doing a proportion, is this one right here. Yes or no. Okay. And then if you're up here, you just smooth as, slow as fast. If you're down here, then you can use the Mike TV table for both alpha half and that z-score. Your z-scores are right here. But if you're up here, you can't use this table with the exception of the alpha half values, because there's no z in this formula right there. Okay. Alexa, what do you think you would respond to B with? So the mayor wants a more accurate estimate. So what could Batman do to achieve a more accurate estimate?
I said to increase the sample size so that the interval would become narrower.
Okay, good. Or what's another thing that let's call on someone else who I haven't talked to, or we haven't heard from. Delaney, what's another thing you think Batman could do to increase the accuracy of his estimate?
Okay, here we go. He could double check the data he collected.
Yeah, I mean, he's Batman. He doesn't have to double check anything, but okay, he could do that. What do you think, Colin? What's another thing he could do?
I think it has something to do with the percentages of the confidence interval. Would it go to 99 or 90? Would it go to 99?
So here's the thing that's counterintuitive. The more the confidence interval, the higher the percentage, the less accurate it is, because it's getting away from the mean.
Gotcha.
It's kind of like we have this big bucket and we're saying, oh yeah, but if we want precision, because the wider that interval it gets, we're saying stuff like, yeah, it's anywhere between 25 miles and 12, that kind of stuff. But if we want accuracy, we want to say stuff more like, yeah, it's between 17.5 and 21.5.
Gotcha. So you would want to move it to 90 then.
Exactly.
Okay.
Exactly. So he could do both things. He could do all three things. He could increase his sample size. The problem is right now, he doesn't have a whole lot of time to get more information on the Joker's past bomb history. He's got what he's got. That's why he's going with the T distribution in the first place. Okay. Let's move on. Keeping track of time. Travis Gould, what do you think about C. The mayor says, you're Batman. You're always confident about everything. Why aren't you 100% confident now? How should Batman respond?
Sorry, I forgot I was muted. Let me pull it up real quick. You said C?
Yeah. Q3C.
Yeah. C. I said, where's that at? C. I said that if he was to respond to the mayor, I said that he should say something along the lines of, the confidence that we're talking about refers to a statistical measure, so you cannot possibly be 100% on a statistical measurement like this.
Okay. I like where that's going. Take me one more inch. Why can't I be 100%? Think technically. Think about the normal distribution.
Because there's always going to be something on both sides, like going out. If we're talking about the normal distribution, we're always leaving the far right and the far left out.
Why do we do that? Where does the far left go?
Forever.
Right. Infinity.
Yeah.
Contrary to what my dad believes. And the same on the other side because it's symmetrical.
Yep.
So you're like on the verge of the end zone. I think you got it. The bottom line is it's infinity. So you can't be 100% confident. And in this context, like Travis said, the confidence refers to the ability to capture all of the potential values for the population mean. And so if there's an infinite amount of values, we can't capture all of them. We know that those tails come off the distribution about that high, like this. So we kind of don't care. You know what I mean? Beyond that tiny bit. All right. And I'm going to post this solution and you might find some humor in what I wrote for Batman and his response to the mayor. Anyway, so that's kind of an Easter egg thing for you. All right, let's finish up with this. Let's go to Q4 and let's Chastity. Why don't you give this thing a shot?
Hello, I'm sorry, I didn't do Q4, so I'll just look it up real quick, see what it is.
Okay. You just go for it, and I mean, what it is.
The laptop takes long to download.
What are you doing?
Okay, so confidence interval for the proportion of citizens. So that's just, I'm sorry, I can't find you. That's doing the whole, what we were doing earlier with the, is that the X, not the X, sorry, I'm trying to find it. The X bar, what is it? P plus minus Z with the, I can't even find it, what I'm looking for. Oh, okay, so X bar plus minus Z, the O with the circle, the line across the top, and then the N on the bottom.
Yes.
Okay.
Yes. So we're talking about this. Actually, it's right here. That's what you're talking about, right? I don't think it is.
No.
You talked about sigma.
Yeah. So.
All right. So we got to make the right formula, but we're in the right forest. Okay. So we're going to do a plus or minus with this formula right here. Now, Lauren, how do we figure out what P is? If we're going to use that formula, how do we figure out what P is?
Is P the population?
So remember, P is the sample proportion.
I'm not sure.
Okay. What do you think, Delaney?
Yeah, I'm not sure either.
Okay. So what do you think, Colin?
Would it be the 675 plus the 439, which would give you 1,114?
Okay. What's that 100? What's that 1,114? What is that number?
Isn't that the P?
Close. So the P, let me just, because we're starting to get into our, turn into a pumpkin zone. All right. I just somehow have flashbacks of that guy at North Dakota State University that used to do this every class period. All right. So I apologize for this. So here we are. And we want to do a 99% confidence interval. Okay, super. This reeks of proportion. And of course, this word is a dead giveaway that we are down in this forest and we are chopping down that proportion tree. That's where this is messy, is we want to skip over this whole thing, go over to here. Super. What is P? Well, what is the confidence interval for the proportion of citizens who will not evacuate the city? Okay, that's all these knuckleheads that answered no. So like Colin, where he was headed, that's this. 675 divided by 1,014.6059. Remember, proportion is exactly how it sounds. It's less than 1. If anything, it's 1, but it can't be more, okay? Because you'll see right here, if everybody said no, then it would be 1114 divided by 114, and that'd be 1. But it wouldn't be 2, and it wouldn't be that. Okay, so this number here, this 1114, that is actually N. That 675 is the characteristic we're interested in, which is X. So X divided by N equals P. In this case, that's 0.6059. And from here, really, it's just a matter of knowing what we're doing. Because we're doing a 99% confidence interval, we're going to use that Z value of 2.58. So we're going to go in here, take that 0.6059. That's going to be our P. And then we're going to do the rest of this math. And in the end, that's what our interval looks like. Okay? The proportion of the population that will not evacuate Gotham City, because this is just a sample, is somewhere in between roughly 57% and 64%. Regardless how you slice it, it's more than half of the people in Gotham will not evacuate the city, even if they are ordered to do so. Which leads us to the million-dollar question: what does Batman tell the mayor they should do? So, Matt, what do you think?
I think he would tell them to evacuate anyway.
Why do you say that?
Because the probability of the Joker dropping a bomb that could affect the entire city is significant enough.
So I actually disagree, because based on the data that we have, the probability that the Joker would drop a bomb that would affect the the city is actually very low. Remember that once we got into that sample mean, the probability was less than 1%. We also know that we have a confidence interval here that the bomb is somewhere in between 8.48 and 9.97. And remember, the radius of Gotham City is 20. So our confidence interval says that the actual population mean for the bomb is even less than half the radius of the city. And then the last thing, oh, I'm sorry, I'm sharing something you can't see. The last thing is this information about the proportion, which more than half of the proportion of the city wouldn't even evacuate even if he ordered. So he would think that he's going to get an outcome that he's not. So I would make the case that based on our analysis and the information we have, that Batman would say, don't do it. Do something else. Do something like a partial evacuation or something like that. Okay. I'm going to post this probably later today, definitely before the end of tomorrow. I'll let you know when it's posted. Any questions before we start to sign off from anybody about anything?
Hey, I'm sorry, my dogs are acting up. But I did the survey and I put down that I would like to go over confidence intervals, but
Okay.
I would also like to go over sampling as well, please.
Okay.
All right, thank you.
All right. Let me show you guys just one quick thing, numbers wise, on how to generate notional data. This will take me about, it'll take me more than 2 seconds. My son always says this. He goes, Dad, it took you more than 2 seconds. You're right. All right. So let's say that I would have had this coronavirus thing not happen. I would have looked at routes and how long it takes me. Let's say I have route A and I have route B. And I think that one route, my suspicion is that one route takes me between, I got to do an equal sign. Takes me between 12 and 15 minutes. Okay. And I'm just going to notionalize that. And let's just keep it at that for now. So I can drag this and get a bunch of random numbers between 12 and 15. Now, and I could use that and pretend like that's actually what I collected. So I drove this route how many ever times? 12 times. And the first time it took me this, second time, et cetera, et cetera. Now, that's super, but what I need to be careful about is if I'm going to use that data, I need to park it somewhere where it won't change. So I'm going to put it over there. And even when I pasted it, it changed. I think I have to go back in here and say values only. And no, see, it's going to change. So I need to accept the fact it's going to change once. But now, watch these values on the left, watch the ones on the right. So if I say hello, and then I hit enter, the values on the left will change, which is what I don't want. I want the values not to change so that I can work with them and analyze them and all that. So that's kind of what I've got to do. The point now is that I have how many ever numbers that were randomly generated between 12 and 15 that I can move on with my analysis with. So I just wanted to show you that real quick. I'm not going to go on and on with that, but that is a way, or you could just manually pick numbers, at random between 12 and 15. But this kind of got the thinking out of it where I can make sure that it was indeed random. So with that, I just want to say, don't get bummed out by this exercise. Do stay with it. Do study it. Do identify what you want to work on some more. Communicate that to me in whatever way works for you. Continue to ask questions and see how I can help you and how you can help each other. I will hang on the call until everybody's cleared in case someone has some questions at the end. But otherwise, you all have a great weekend, and we'll see you on Tuesday. Take care.
I have a question real quick.
Okay.
Would it be possible, or I don't know if it's already posted, but is there like a document of like the formulas, like how we're supposed to put them into Excel?
There is. I'm trying to remember on what day. Let me look real quick.
Okay. Because I was trying to look around and I couldn't find it.
You gave us a paper like that. Like a
Yeah.
paper with all the formulas on it.
As we
Yeah,
used to
I remember I do have the paper, but it's in my apartment at school, so I obviously won't be able to find that.
Yeah, worry not.
Okay.
Can you see my screen?
Yeah.
All right, super. We will find it.
Okay.
Well, I think it was before that time. It's not there. I would have thought it would have been there. It's here somewhere. Let's go back. I'm sorry. I know this is like watching paint dry.
No, that's okay. This is what I was doing earlier to find it.
I want that to be it, but I know it's not because it's not an Excel file. Well, it's definitely not there. Went too far. Maybe that I thought I posted it and I didn't. Yeah, I think I've gone too far. I don't think it's there, but I've got it. So I need to post it. So
Okay.
I'll add that to my list. So I won't waste. I just look one more place. No, this is stuff that that's stuff that you guys can't see anyway because that's from last semester. So Anna Grace, I will find it and post it, and I will let you know where it is.
Okay.
When I do.
Yeah, that'd be very helpful.
Yeah, of course. Super. Yeah, I don't want you to go back to your apartment.
Okay. Cool. Thank you.
Cool. You bet.
Have a good weekend.
Hey, you too. Take care.
Thanks.
I just had a really quick question about the project.
Okay.
Are we like when we like get this data, I'm like just kind of confused with like are we using everything that we've learned like so far, or is it from the first test, or I'm just getting confused.
Now, so again, I'm going to do this weird thing, and I'll give you the kind of semi-short answer. So the short answer is it's not everything. It doesn't have to be. So
Okay.
for example, you could just do something on descriptive statistics if you wanted to, using descriptive statistics. So you could say, I'm in the photography club and I'm kind of curious about the people who are in the photography club. I'm curious about what majors that are in the photography club. And so there's 20 people in there and 5 of them are marketing majors, 12 of them are music production, blah, 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 blah. You see what I mean?
Mm-hmm.
So when we do that, we're not necessarily using anything from the second, from, you know, from that point of the course to now, and you don't have to.
Okay.
Alexa, can you see this when I'm at?
Yeah.
So I don't know if I always had this published, but if you get a chance to read through these,
Okay.
they'll tell you and walk you through the whole thing. But the bottom line is it's really just, in fact, let's just pull it up. It's really just a portion of, if you want to use sampling, you could use, inferential statistics. Here I go again, doing what that guy did. But down here, you kind of say, you generate a question. So you could use descriptive. Here's the whole wristband versus stickers question. So
Okay.
here I would use sampling, and I probably wouldn't use descriptive. Does that make sense?
Yeah.
And so in essence, and I think I even have it in here, like you kind of know that I don't know. I thought I put it in here where if you do this right, you're almost kind of writing a problem that I could use in the future for people.
Okay, I was just gonna say that like we're building a question and like describing it in depth and everything.
Yep.
Okay.
And it doesn't, and so it you could use sampling, you could use confidence intervals, or you could just stick with descriptive statistics.
Okay.
Remember, population to sample,
Yeah.
or population to small, general to specific is descriptive, and then specific to general is what we've been doing with sampling on out.
Okay.
So you could do either one of those, but you don't have to feel like you have to use every single thing.
Okay.
That
yeah, that's what I was just like making sure about.
Yeah, I mean, just read through that or skim through that and think about what interests you and how you could use some D3M stuff to kind of learn more about it. And now, because the data is kind of potentially made up, if you don't have the data, then it's still worthwhile, because it kind of gets you thinking about, well, if I had to guess, what would the data look like?
Yeah.
Does that make sense?
Yes, it does.
All right. How's
Right.
everything else?
Good. Stressful but good. Everything.
You mean with all this online stuff,
Yeah,
or
it's going smooth, but like it's obviously still stressful because it's just different.
yeah.
So
Yeah, it's I hand it to you guys, and there's some folks who are probably having a tougher time than others,
yeah.
just because it really requires you to be organized.
Yes.
So all right, cool. Well,
Right.
have a good night.
You too. Have a good weekend.
All right, you too. Take care.
Bye.
Bye-bye.